And this is pre-calculus, the lesson for the second day of section A3. So A3 day 2. And let's see what we've got going on here. It says simplifying another compound fraction, use the LCD to simplify the compound fraction and use the new method. Now I'd stopped with A here, and we want to give B a try. So let's see what's going on with B. I definitely need more room here. So first things first. This is really what we're doing. Fraction divided by a fraction. So this will be x to the third over x plus 1 divided by, now, why did I just rewrite that? Well, because this one doesn't have a denominator in factored form, and I need to have that. And I'm looking at this thinking, well, maybe this is one of those perfect square trinomials. Let's see here. X times 1, you double it, and you get 2. Oh, yeah. That's going to be x plus 1, the quantity, squared. So remember, our new method is we're going to figure out what the LCD is, and we're going to multiply these by the LCD and see what happens. So now it's LCD time. And I see I have a denominator of x plus 1. That has to be there. And I see not only do I have x plus 1, I have x plus 1 squared. So remember, to find your least common denominator when we have those polynomial factors, we have to take all of the factors into their highest power. Because with fractions, we can build them up so that they can be the same, and that's what we want to do. So now, what do? Well, the new method says we can go ahead and multiply by that LCD, but before I get too far, I want to start thinking about my domain and what would be bad. So I realize, well, I've got an x plus 1 in the bottom of both of those as denominators, so x is not going to be equal to negative 1. Not going to work. So there's the first part of my domain restrictions, realizing that. Then I decide I am going to multiply by x plus 1 squared. Both of these. And when I do that, I see that one of these x plus 1s is going to be gone. So the top of my fraction is now going to become x to the third times x plus 1, because my denominator was 1. And again, this is my upper fraction. Now on the bottom, I see that I can take both of those x plus 2's out, and I'm left with top times top, bottom times bottom, a value of x. Now, what do I do? Am I done? No, but we have to stop because we have a new restriction in the domain. Look at our new denominator down there. That's x. If it's 0, we're in trouble. That doesn't look like a 0. There we go. Because now we'd be dividing by 0. Now we want to do that before we go any farther. And we say, well, that worked out pretty slick. All right, well, so now all we have to do is figure out if we can cancel. And the answer is yes. This is multiplication taking place right here. When two things sit next to each other like that in algebra, that means that's multiplication. So this x can cancel out one of those x's. And we have x squared times the quantity x plus 1. So there's our answer, along with our restrictions on the domain. Pretty cool when we multiply by that LCD. Lots of things happen very quickly. So we have some extra practice on this page, and this is something I really would encourage you to pause the video, give these a try, and see what you can do with them before you just, press play or sit and watch it roll by. I want you to see if you can do these, get those domain restrictions right, and then start it back up to watch to watch me do the problems. Okie dokie. So let's take a peek here at A. Looking at A right away, I want to think about all the stuff that's going on with my domain here. and realize that I have an x and a y in the denominator, and whether or not it's x squared or y squared is irrelevant. We're not going to be able to use 0 in the denominator for those, or this problem you wouldn't be able to do it. And then the next thing I have to do is figure out that LCD. And I realize, all right, I definitely am going to need an x and a y, and I'm going to need them to their highest power. Well, that's x squared and y squared. So what do we do with that? Well, just what we've been doing before. You multiply every single term by that LCD. So we're going to multiply this x over y times x squared y squared, and you can think of it as over 1 if that helps. And then we're going to multiply this one by x squared y squared over 1. We're going to multiply this one by x squared y squared over 1, and this one by x squared y squared over 1. And after a while you get kind of sick of writing the 1, and you just want to remember, oh yeah, you know, those things will cancel out. So we're going to take one of these y's out of here, and we will have x squared and another x, so x to the third y, minus here, this x is going to drop out, so we'll have one less x up there, and we will have x, y to the third. All right, I don't want that running into my LCD over here. So far we've got the new numerator here, x cubed y minus xy cubed. Now let's go after our denominator, which the x squareds are going to cancel out, and we'll get y squared. And over here the y squareds will cancel out, and we'll get x squared. So now, do we have a new restriction on the domain? Well, yeah, because if x squared, actually let me write it the way it is up there, y squared minus x squared equals 0, we're in trouble. That's our new denominator. So we would add x squared to both sides, and we would realize the only way that's going to happen is if y equals x. I mean, if we take the square root of both of these sides, that would be bad. So new domain piece here would be y cannot equal x at this point. Now what we need to do is we need to look at what would happen here if we were able to do some factoring. So let's see. Our numerator there, if we were able to factor something out, that something would be an x and a y. So let's see what happens. If we take that out, we would get x squared minus, well, let's see, if we take an xy out of the back one, we'll have y squared. Golly, should be something more we can do with that, isn't there? Absolutely. And that's because if we just divide our denominator by a -1, it'll reverse it. Now we didn't get a new domain restriction at this point, but what we're going to do is divide a -1 so that we can reverse. Remember, a -1 will give us the opposite of everything that we have. So that will give us a positive x squared and a negative y squared, and that will work out perfectly. And we check that out and we say, well, now we don't even have a denominator anymore, so we're not going to have any more domain restrictions. There's our answer. And there are our 3 domain restrictions. X can't be 0, y can't be 0, and y can't be x. And obviously I write too big, so I cheated, and I put this one up here. So this one has division, and what you have to remember is you have to write it in factored form and find all those restrictions on the domain before you flip. So on the top here, this is a difference of 2 squares. 2y plus 3, 2y minus 3. On the bottom, we've got our little 2y squared plus 9y minus 18. It's not a perfect square, and we say, all right, pretty obviously that's going to be 2y and that's going to be y. And with -18, our choices would be either -3 and +6, +3 and -6. And you might come over here and do our combo method here, but I probably wouldn't even write 1 and 18 and -1 and 18 down. We need a 9 in the middle. So those would be the things that we should try here. So we look at that and we think, well, what would make more sense? Oh, Well, if I could get a 12 and a negative 3, that would do it. Outside times outside plus inside times inside. 12 minus 3 is 9. So we've got our 2 and our 1, and we need a negative 3 and a 6. And again, you could just get that by trial and error. Put some in there until things work out nice for you. So that's what we have in front. In the back, well, got another one with a 2 in front. Boy, oh boy, do they love the 2. Well, in the back, it's negative 3. So, you know, this is not going to be horrible. So what we would want to do is use a positive 3 and a negative 1. And again, you could use a little trial and error there to get everything to work out for you. On the bottom, we needed two numbers that multiplied to negative 6 and added to 5. So that's going to be plus 6 and negative 1. So now what? Well, first of all, I better change my x's there to y's. Good gravy. All right. So we have all of this. Now what do we do? Because there always seems to be so much that we have to take care of. Well, we have to stop so that we can go through and make sure we have the domain restrictions at this point. And our domain restrictions would be, well, 2y minus 3 can't equal 0. So you'd add 3 divided by 2. 3 halves is bad. All right, what else? Negative 6, it's bad. Makes a 0 in our denominator. Same thing here, but a 1. We'll do it there. And we know we have to flip this, which means we're going to be right back here in a second talking about our restrictions in the domain. So whatever we're dividing by, we're going to flip. Got her flipped. We check for new restrictions on the domain. Well, now it's 2y plus 3. And we, of course, realize that's going to give us a negative 3 halves when we try to solve that for 0. All right, so we've got a negative 3 halves, and we have another 1 down here, but we already have that listed. So back up to our domain, y cannot be negative 3 halves. Now we can start canceling like crazy, because I'm sure by now you thought, geesh, I really want those out of there. 2y minus 3, top and bottom. I really want those y plus 6s out of there. I really want those 2y plus 3s out of there. And I really want these y minus 1s out of there. Wait a minute. So what's our answer? It's 1. That is cool. That is brilliant. That is amazing that says 1. That's math for you, folks. Math is fantastic. All right, let's go back here. We had a couple down below that you still needed to go after. So, C. Yeah, we got to have a common denominator. That's a plus. But the one good thing about this is once you find that LCD and you find your restrictions in the domain, you're done with this unless you didn't find the LCD. And that's because you have to have the least common denominator in order to have this work right off the bat for domain. If you get something too big, then you're going to have spares, and we don't want that. So we do definitely have an x plus 5 as a denominator and an x minus 3 as a denominator, and that is to their highest power. That's it. So what we're going to need to do is build them up, because that's what we can do to make fractions equivalent. We can multiply them by things that'll make it work, and that's because if we multiply on the top and the bottom, we're really just multiplying by 1. X plus 5, x plus 5. All right, so the first one will be x minus 3 over x minus 3 times x plus 5 plus 2x plus 10 over x minus 3 times x plus 5. Now let's go ahead and add across the top there, and we have 3x plus 7 over the quantity x minus 3 times the quantity x plus 5. And if you look at it, you realize, oh, yep, we got all the domains covered if we just say you can't use 3. And you can't use -5. You just don't want to forget to do it with addition and subtraction. You always want to make sure that you come back to it. Now, how do I know that I am done? Well, I don't see any matching factors. Remember, that 3x plus 7 has addition, so if we're going to be able to cancel anything, we would have to have a factor that is exactly a perfect match for it, and we do not. So now what? Well, D, of course. Let me see if I can just move this little bugger, because as usual, I need more space. I write large, because there's people in the back of the room that need to see it. So, well, that looks very, very basic compared to the other ones we did. We're going to factor it to see those restrictions on the domain. And we need two numbers that multiply to -20 and add to -1. Well, that will be -5 and +4. Let's go down to the bottom there. A 2x and an x. In the back we got a -4. In the middle, we need that to somehow give us 7. So I think if I could get 8 and then subtract 1, that things would be good. And that 4 going right there would be 8. -1, outside times outside is 8x. Inside times inside is -1x. Last times last would give me my -4. Now, don't cancel just yet. Domain restrictions. Well, we know we can't use -4. And if you think about it for just a second, your 2x minus 1 equaling 0 would be x equals 1/2. So x can't equal 1/2. All right, now we need to cancel. And we have x minus 5 over 2x minus 1, and we ask ourselves, should we have any new domain issues? No, obviously we already talked about 2x minus 1, so this is good to go. There's nothing else we can do to it, and there's our domain. Beautiful. Hope you had fun with those. Those are fun little problems there. I always think they're like little math puzzles. So again, same assignment that you had, which is this one. So pause the video if you need to write it down again, but you should be able to finish up the whole thing now.